So code fuzzing, as I mentioned in the safety aspect, is basically a really quick way to validate input and confirm that we're catching all sorts of invalid input. So when we say fuzzing, we don't mean fuzzy animals or something like that. What we're actually talking about is putting random stuff into the code and see what happens, right? So it's basically brute force, put anything in, see if we get some interesting error messages. Valid error messages are basically not interesting, so we're going to get a few different outputs, right? We could get valid error messages. That's kind of boring. But anything that's like a crash or an invalid error message or unintended behaviors are very interesting for us. So if you're fuzzing a system, right, you can do this to basically anything, even manually. So here's a really simple example of like a system, right? So here's a system that I can search something on. So if I want to search my name, right, and my name has an apostrophe in it, comes back with nothing. But you can notice it's clear the apostrophe from my name. If I put a blank, so if there's no last name here, right, it says you did not enter anything. So what happens if I just put, so clearly it was clearing invalid characters. So if I put like an ampersand in my name, right, it cleared that out. What if we just put a bunch of garbage in there? Right, so fuzzing would just be, and this would normally be done with a computer, right, to insert garbage, and we just got no records. That's fine. But what if we put all special characters in here, right? Then we get some sort of other error. In this case, it's just clearly, this isn't like a real crash, right? All that's happened is it's internally removed that input and passed it, it's passed one layer more than it probably was supposed to before it realized there was an error, so we got a different message. So nothing too serious there at all. But fuzzing fundamentally is just presenting random data and seeing what happens to the device. And the more interesting fuzzing is always going to be the lower level interfaces we can get. So in this case, just what the user's entering is probably validated, but what another system enters is probably validated a little less. So in the previous example, the user, it catches if the user puts nothing in. But when I put invalid data in, what happened is internally it stripped the invalid data and then passed it to the next system. But it didn't give a nice error message if it stripped everything away, because it always assumed the previous system had already done the stripping, so it didn't need to validate it. So that's a really, really basic example of, fuzzing. Nothing too interesting, but the idea is there. We have three main types of fuzzing. So the first two are the real ones you're going to come across. The last one's sort of like a research area. The first one is mutation-based, and this is just where we're doing random mutations. So we just randomly are changing some of the data and seeing what happens. The smarter way is basically we define a specific format and we know something about what it should look like. So with a file format or protocol or something like that. Excuse me. And the final way is actually using some sort of automated feedback. Dumb fuzzing is the most basic way of doing this. We would just randomly throw data in. That was like when I was just hitting the keyboard. We don't know if it's going to be valid or not. The risk here is that if you think about, say, a protocol, it typically has like a checksum, and you're not going to that's not going to be valid, so you're not going to catch that. Smarter mutational fixes will at least fix those dumb mistakes. So that's kind of how we had two types, smart and dumb mutation. Smart means that we're not paying a lot of attention to what we're inserting, but it's somewhat valid. So if we're fuzzing, a phone number field, maybe we make sure it's the right number of characters. If we were fuzzing a network protocol that has like a CRC or a checksum, we make sure that checksum for at least some of the fuzzing is actually valid, so it goes to that next level of processing. This is the least effort though. Generation-based, basically, you're going to look at the specification, you're going to look at the format that it's expecting, and you're going to specifically attack or fuzz or insert random data at different locations. So it's more effort to set up, but you know, like I'm fuzzing the file type, the file length, file name, things like that. So it's more likely to cause errors because you're really targeting what you're doing rather than just sending all sorts of all random data. The final type is what they call evolutionary. So this is more a research area, to be honest. But basically, it's like generate a test case. You try to have a program that's actually watching for outputs. So if it detects, hey, when I adjust only bytes 4 and 5, I get different output than, if I try to randomly change all the bytes. So let's concentrate on that. This has a lot less concrete examples. So the first two, there's lots of frameworks and programs you can find. This one is more kind of an open research area. But yeah, that's kind of a real quick, I know that's a fast overview of fuzzing, but it's a good way to find bugs in your code. So rather than doing, purely just testing based on data we expect to be valid or invalid, it's more likely to catch potential problems. And with a little effort, we can get good coverage of the most likely error conditions that we're going to run into. So this comes up a lot in security testing, but I also bring it up in the safety aspect, as it's also a good way for validating code safety.